We're going to talk about openings. We did openings in floor the last lesson, and so how do we get into this building? That's something you need to know, right? So there's an entrance at the what is the southwest facing corner of the tower. This chamfer forms, you have this round opening, a very tall opening, and a opening that's doorway size in there, right? There's a big opening in the floor somehow, which we'll need to model. That gets us to the basement, it appears. So, the AutoCAD drawings have some consideration of this, right? So if I draw a rectangle about this size, I'm just going to move it over here and measure it. "10 feet. And then in height, it's about 34 feet. We have a circle, presumably that circle fits into, similar shape. So I can say with some certainty the diameter of that circle is going to be 10 feet. All right? So I'm abstracting, and then somehow between the first floor and the second floor, an opening for a set of doors was developed. Right. My SketchUp file, I can bring in the drawings that form those elevations. I believe we copied them out separately in AutoCAD. I'm going to save. I did save this as a Windows lesson, but if I align my view to that side, if I decided to draw starting at level 2, an opening "10 feet, 34 feet. That's what I have. I have something like that. I haven't drawn it in the right place, and the circle is above it. Just going to delete that. Let's go to an isometric view. So the entrance to the space is here, right? Let's close this group. Let's examine the CAD drawings for the elevation views. I'm pretty sure I wrote these out as blocks. So the elevation is the southwest one. So let's open that CAD drawing, the southwest elevation. And remember, we had trouble importing these into SketchUp, so we're going to save the drawing as version 2013. Why am I focusing on a single elevation? Because this is a very symmetrical classic building. It's highly formalized. If I can solve any part of it, I can propagate that understanding to different openings, right? Because if you look at this building, these systems are very much the same. They're different in height and breadth, but they're very much the same. They're large vertical openings, some in this case broken up by spandrels, with arches, semicircles at the top. So I'm setting all that aside right now in order to understand basic opening, and with a view towards modeling the entry, right? We're going to solve the problem of the entry, and if we solve it on one corner, one of those chamfered corners of the building, we can propagate that solution to the four corners. Back to the SketchUp model, and let's import AutoCAD. There's the southwest elevation. The good thing about AutoCAD is that we don't have to worry about scale. So there's my CAD drawing. Let me move it forward. We're going to want to rotate it upwards. Rotate. Let's set the protractor to one side, and the red axis is 90 degrees so that it's aligned vertically. And then we want to take in plan and rotate it 45 to form the chamfer, right? There, I'm going in that direction 45 degrees. So this is correctly aligned. It is not yet in the same plane or the same place where it belongs. That can easily be put there by selecting this object and dragging it from that endpoint and placing it right there. It's very important to understand what I just did, because if we can solve the problem of how this element is modeled, we can solve the problem of the other four sides and come up with a strategy for the rest of these openings. So I'm going to save this file at this point. Let's make sure we have a layer to, oh, and don't forget to collapse the AutoCAD layers. Move the contents to the default layer. There's two more. Move the contents to default layer. And let's create a new layer for AutoCAD Southwest Elevation. And take this drawing and move it to AutoCAD Southwest Elevation. File. Save. So this is Windows, but it's really just the beginning thereof. I haven't modeled anything, but I've set up the drawing to do so.